Okay. I'm Alex, and I go to university, which is this big place that causes extreme misery and mental anguish to all those who go to it. But nonetheless, I study physics and math, so clearly I wanted all of the misery. But it's okay. It turns out I can do some things with that knowledge, and my first decision is to figure out just how strong the strongest Battlegrounds actually is from a physics standpoint. Okay, don't get bored yet. Let's just get going. So to start off, I actually needed to find a way to make the distances make sense to real-world calculations, and for this I found that a character is roughly 5 studs tall, 5.33 to be more exact, and that one stud is approximately 28 centimeters. So I made a stud block in TSP build mode and checked it against my height to see I was just around 5 studs, albeit a little bit below. And I figured that to start, I would just see how much force is actually behind one of the punches in the main combat combo. So attacking the dummy, I realized that attacks move it forward a small amount, but this isn't an issue as long as I marked where it actually began its flight path after the 4th punch, and it was roughly here. So I switched the grid to accommodate my 1 stud block, and I found that the dummy had moved roughly 22 studs ahead of me and about 9 to the right, but I originally said 8 in game because I forgot to consider the length of the corner stud, whatever. From that, we got a distance of 23.7 studs, times the 28 centimeters per stud, divided by 100 to give us 6.65 meters approximately. That's just Pythagoras and normal math. So now, using the knowledge that displacement is actually equal to half times acceleration times the flight time squared, using some trimming on the clip, I can find out that the flight time is 0.8 seconds. So we'll rearrange that formula for acceleration, which gives us acceleration is equal to 2 times displacement divided by time squared. Hence, we have that the acceleration is 2 times 6.655 divided by 0.8 squared, which is about 20.7985 meters per second squared. And that's not bad. That's actually kind of fast. Now, force is mass times acceleration, so let's be humble here and suggest that the average Roblox character weighs the same as the average person of their height, which is about 4'7". The average weight is between 60 and 85 pounds, but that's a freedom unit, so let's convert that shit to SI units, and we get kilograms of between 30 and 38 approximately, which is quite light, but anyways, force is mass times acceleration. We get a lower force of about 623 newtons and an upper force of 790 newtons. Can you guess if that's about right? I mean, it sort of is, but I found that some athletes, like boxers, can have upwards of 1,500 newtons of force behind their punch, so I'm thinking that our strongest characters aren't actually so special. Even if I were to take into account the friction of the floor and the air resistance in this world, the force doesn't increase drastically enough to suggest a really powerful character. That being said though, we know that there are some pretty insane moves in this game, so let's take a look at some of those, shall we? I really wanted to take a look at the serious punch, and my first thought was to analyze this one in the same way I did the normal punch, but this punch sends the lucky recipient of its force really far in one direction, so I wasn't sure if I'd actually be able to estimate this. I decided to mark a point on the longer side of the map and try punching the dummy in that direction, and it appeared that first I'd have to figure out how to run there fast enough to see the crater. I quickly realized, however, that no crater was actually forming when the dummy landed. Since I was too lazy to ask someone for help, I decided to try it about 5 or 6 times, and eventually I realized that from this mark, the dummy was fairly consistently landing on this road on the far side of the map, which is quite a distance, to be honest. I quickly built up this 50 stud ruler and found that the distance was about 834 studs total, which would be 23,352 centimeters, which would be 233.51 meters. I checked the clip and found it took roughly 2.25 seconds for the dummy to fly all that way and crash down onto the ground. This was actually a bit of an oversight in my first calculation with the normal punch, since I included the time it took the dummy to stop moving, but regardless, the punch was still not impressive. So now we do the same calculation and find the acceleration to be closer to 92 meters per second squared, which is almost 5 times greater than before. So we get a lower and upper force of 2,767 newtons and 3,505 newtons. Okay. So we're seeing a problem now, since this is the punch force of a human boxer, sort of, so I've never seen a human boxer send a guy flying 250 meters. I don't know about you. It's at this point I began to think that perhaps because the characters are so light, we're seeing extreme effects on them regardless of the magnitude of the force. We know from Newton's second law, which is the one I've been using, that essentially the lower something's mass is, the easier it is to accelerate it. Think about this. If the characters instead were much heavier, closer to more realistic weights, I'll use something around my own weight even. A 75 kilogram person accelerated at that speed would actually require more of a force closer to 6,918 newtons. Now we're talking, right? That's roughly the same force as is exerted by something that weighs 705 kilograms just sitting still on the earth. To break concrete, forces of over 3,000 newtons are required, and clearly we have that. I suppose the only unrealistic thing about this is that we're assuming the force is only occurring at the point of impact. Given that these ultimate moves usually destroy entirely or to within an inch of life, that might be true. However, we see some massive adverse effects happen all around the user. As an example, let's just have a look at the Hero Hunter's ultimate, where you smack the ground and everyone goes up into the air. I can build a 100 stud high ruler and see the dummy goes up to the 85 to 90 stud zone within 0.9 seconds. That alone is 25 meters in 0.9 seconds against gravity, which means we actually now have to manipulate our force equation just a little bit, and we'll see that the acceleration is 62.2 meters per second squared, and our force will be mass times acceleration plus gravity. So we get around 2,736 newtons, but that's for our light dummy. For our more realistic person, it's closer to 5,400 newtons, which is still a lot. Now this is where something interesting crossed my mind. We have to take into account that this force seems to be applied in about a 200 stud area radially from the center. That's an area of pi times 100 squared, which is 31,415.9 studs squared. In essentially every one of those studs, this large force is present. Now, rather naively, we can argue that since this force doesn't really differ depending on how many people are in the circle or how far away they are from the center, the force seems to be applied to every target in the circle simultaneously at the same strength. In theory, if the number of targets is to tend towards a massive number, the total force being applied is also tending towards an even more massive number. If you have 10 targets, that's 54,000 newtons of force, and so on and so forth. Let's just say that every stud has that same force running through it during this time. That would be 31,415 studs times 5,400 newtons of force, giving a stupidly large grand total of 169,641,000 newtons of force. Now that is stupid and unrealistic and wrong, probably. My calculations are based entirely on the silly perspective I have of what's going on, because I can do that. It's a game and I'll interpret it however I want. In this supernatural and fantasy perspective, technically these characters scaling their force output and hence their energy output to account for how many people are in the radius is equivalent to someone producing infinite energy and force. What I'm saying is that the strongest Battlegrounds is actually strong. Like unrealistically strong, universe-breakingly strong. So that's a conclusion.